October 1987, 2 p.m. Space. Space Shuttle Commander Lawrence Yeti performs routine maintenance on the hull of the Shuttle Enterprise. Suddenly, he feels a cough coming on. He coughs. A moment later, his feet fall asleep. The readings on his bodyometer confirm the worst. Space fever. Yeti needs to get back into his spacecraft immediately. He reaches for the shuttle door, but before he can get there, he loses his hearing. Now disoriented, he goes colorblind, then regular blind. Just meters away, the commander's crewmates, oblivious to his predicament, enjoy a playful afternoon space snack. Yeti's body temperature plummets. He vomits. Suddenly, he is filled with nostalgia. Then his ears start ringing, which he cannot hear because of going deaf earlier. He vomits again, and now starts the explosive diarrhea. In the next minute, his entire body will pop. As the shuttle commander drifts helplessly away from the Enterprise, we are left to wonder, will man ever truly conquer space? The answer is fascinating. Space, a vast expanse stretching tens of hundreds of miles in almost every direction, tantalizing us with its celestial prowess and dark impracticality. The universe is a place filled with overwhelming beauty and bothersome danger. Throughout history, starry-eyed cosmetologists have gazed into the cosmos in hopes of finding answers to the fundamental questions of our existence. For centuries, we have struggled with profound questions like, what is our place in the universe? What lies beyond space? Is there life on other planets? And if so, how do we kill it before it kills us? Questions like these have led us to so many amazing discoveries. We now know that most stars are not actually star-shaped. We've learned that Pluto is not actually a planet, but merely a planet. We know that comet powder can cure herpes, and we know that the moon is growing, while the Earth is dripping. And most recently, we've discovered that Mars has robots living on it. But despite our advances, we still only know a fraction of the known universe, and an even smaller portion of the unknown universe. When we look to space for answers, she simply responds, much like a drunken fortune teller, with more questions. This, perhaps more than anything, is what makes the cosmos so mysterious, even today. But how did it all begin? Well, it all started thousands of years ago, with a Big Bang, which we call the Big Boom. It is believed that in the pre-universe some sort of tiny spark occurred, either by accident or by God, or perhaps by God by accident. This sent millions of tiny stars, planets, and galaxies into the awaiting emptiness of space. Then these tiny space bodies, most of them no bigger than pebbles or grapes, slowly began to grow, and over centuries, they steadily grew, feeding off the nutrients of the space particles around them, and eventually matured into the majestic interstellar giants of today. But what did this big boom sound like? If you can imagine a sound 605 billion, trillion, thousand, million times louder than that, then you would be hearing something That's about 1/4 the volume of the Big Boom. And it wasn't just, it was, we believe, something more like, think about that.
Our quest began long ago when ancient man first noticed space, initially by accident, then later by purpose, when curious elders stayed up at night in search of the missing sun. In the dark sky, they believed that stars were oil lamps of gods.
The first people to have answers about space were known as astronomers, from the Greek, astronomer, meaning he who gnomes astros. The heavens were first given true critical study by one of the earliest and brilliantest of these gnomers, Ptolemy in 170 AD. Ptolemy, known for the silent P at the beginning of his name, believed in a geocentric universe in which Earth was at the very center. Centuries later, Rudolf Copernicus hypothesized a heliocentric universe in which the universe, which contained the Earth, revolved around the Sun. Shortly after, Deandre Kepler theorized that not only did the Sun revolve around the Earth, but there were two suns revolving around the Earth in what was known as a duo-helio-geocentric universe. Not to be outdone, Copernicus then argued back that there were actually thousands of suns revolving around hundreds of Earths, each of those revolving around its own Sun-Earth hybrid in a milli-helio-geocentric universe. Enraged, Kepler responded, "Fine, how about there's no space?" And using the latest mathematical techniques of the time, he proved that there was no space at all. This led to a period that we now call the Dark Ages. The Church declared there was no space, and doctrine prohibited anyone from practicing the heretical art of astronomy. A time still described by astronomers today as
So dark.
now illegal, the practice of astronomy was relegated to hidden basements and secret clubs. Those who were caught practicing astronomy during these dark ages were often accused of practicing witchcraft, or worse, spacecraft, and many of them, like renowned astronomer Joan of Arc, paid for their illegal space studies by being burned at the stake in the notorious Salem witch trials. Still, there were those, like Albert Galileo, who would not give up on the dream of space travel. For centuries, man had flirted with space, but now it was time to enter her.
5, 4, 3, 2, 1, ignition.
And this is where the story gets fascinating. Next time on Our Fascinating Planet.
Being wrong actually sometimes is a great thing. And this is the thing that we don't discuss a lot. But when you see them land a mission to Mars, you see the NASA control room clapping and applauding. They clap just as hard when there's a catastrophe because we've ruled out something.
Last time on Our Fascinating Planet. A big boom created a universe, and man looked up at that universe to discover space. Brave thinkers called astronomers brought us to the brink of space, where brave doers called astronauts were poised to bring us beyond the brink of space and into the beyond of the brink. incredible. Thanks to advances in modern optical technology, today we can look far into the universe. And what we see is breathtaking. But long before we could use today's powerful telescopes and gigantic binoculars to enhance our view of space, man pointed his naked eyes at the sky and dreamt of traveling into the heavens above. The first attempts at entering space were primitive and often downright silly. Balloons, catapults, cannons, cannon pults, each more flammable than the next. Arthur Kindle describes early space travel as, quote, rife with explosions. Emmett Merriweather famously wrote that it was full of explosions, and Mortimer Appleby III characterized it as, quote, so many explosions. Despite the danger, space enthusiasm was high, and by the early 20th century, the first space planes started to appear, many of which exploded. Still, man pressed forward, and what's known as the space race began. The first human in space was a monkey, launched by the Russians in 1956, as a way of taunting the United States during Cold War I. This led President John K. Kennedy in 1961 to open the Kennedy Space Center. Its mission was simple: send an American monkey into space to defeat the Soviet one that had gotten there first. And with that, the United States space program, known as NASA, was born. Since NASA's birth, we've achieved a great deal in our quest to conquer space. We've launched satellites that charge solar panels for use on Earth. And we now have space stations where thirsty astronauts can stop for a snack while they refuel their ships. And perhaps most remarkably, we have managed not only to leave a flag on the moon, but also a man. But we have also discovered how dangerous space can be. Since the space race began, more than 600 astronauts have disappeared into dark pockets of space, many vanishing without a trace. But where exactly did they go?
The answer is fascinating.
It turns out these pockets of darkness are not so much pockets as they are holes. In fact, leading astrologers like Stephen Hawking of Cambridge, Oxford, have called these dark holes
black holes
due to their blackness and holiness. And using complex equations and powerful magnets, Hawking has proved that these black holes are very real and very deadly. So how do black holes form? Well, space is essentially a gigantic fabric the size of everything. This fabric is constantly being blown by something astroscientists call space wind. The space wind causes the fabric to move and ripple. It also blows the various planets around their respective suns, causing them to orbit. When the space wind gets too strong, it can cause the fabric of space to flap about. When the fabric flaps too hard, stars can shake loose and blow away. The result is what we commonly call a shooting star. When a shooting star whizzes away, it leaves a hole. And this is what we call
a black hole.
What happens to light in a black hole? Have you ever been to the doctor and when they look inside your mouth and they shine a flashlight? It hits the back of your throat and then it just ends.
Many scientists believe that black holes not only devour light, but also other nutritious space matter like asteroids, comets, star dirt, and even astronauts. But how do we detect these black holes? It's easy enough to see giants such as Mercury and its tan hoops, or Uranus and its red anus. But what about space objects that are much smaller, such as black holes, which can often be as small as a typical water slide or even a toilet? Professor Gore Muscope, head of the Space Department at the State University of Space Polytechnic, might just have an answer.
A microscope allows us to view small objects, So we asked ourselves, what if we sent a microscope into space? But then, what if we look at the microscope with a telescope?
With the help of GPS, UPS, and PMS, Muscope and his team pinpoint the position of a given space microscope. And then, using carefully calibrated miniature rockets, they rotate the floating microscope until it is aligned with a corresponding telescope on Earth. The results are nothing short of incredible. Millions of feet from my eyeball, I'm looking in pristine detail at bits of space rock, as if I could almost pick one up and throw it at someone. Or perhaps just give it to them, peacefully. But more importantly, using this micro-telescopy, we have been able to locate hundreds of black holes that would otherwise suck up passing spaceships or astronauts. But it turns out there's a more profound consequence to all of this blowing space wind. We've discovered that space wind is not just creating holes in the fabric of space, it's blowing into those holes and stretching them out. And that is making even more space. Space is getting bigger.
Space is very big and very grand. I mean, there's so much space, especially between the stars and the planets. I mean, all that dark stuff, that's space.
But what does this mean for the future of the universe? As it expands, what will happen to it? Imagine, if you will, that this is the universe. The Big Bang has just happened. 4 billion years. 2.5 million years. 1,000 years. Present day. And then we know the universe will explode, probably in the next 200 or 300 years. So today we find ourselves desperately searching for ways to outrun this ticking time bomb before it kills us. If we can travel fast enough through outer space without falling into black holes, then theoretically we should be able to shoot out of the universe just as it is exploding behind us, which will then propel us safely into the next universe. But in order to achieve this, we're going to have to go a lot faster than we can now. We have broken the sound barrier and are just now traveling faster than smell. However, we will need to fly at the speed of light to outrun our universe. And this presents problems.
Well, there are many theories about what happens when one travels at the speed of light. Some believe you would travel through time. Some say that your body would be stretched like a long piece of spaghetti. Just as likely, some say your body would be crushed into a kind of ravioli, with your innards kind of becoming mushy and then a sort of a soft outer edge. Fusilli. I'm not into pseudoscience. Let's get serious here. I mean, it's probably the spaghetti thing. You get stretched out and, travel through time that way. Spaghetti, it makes sense.
We don't have an answer yet to this puzzle. Some skeptics say it is impossible for man to travel at the speed of light, let alone shoot out of the dying universe just as it explodes behind him. But we must remember, it was also once thought impossible to launch garbage into space, or to send our most dangerous criminals to prisons on the moon. And many laughed at the idea of colonizing Mars by building small mini-Earths, which we will fly to the red planet and then live inside of on its surface. Yet now, all of these things are a reality. Today's leading scientists have almost as many ideas for how to safely escape the universe as there are Milky Ways in our galaxy. The space race continues, but now we know it is not just a race against the Russians or the North Japanese, but against space itself.
We are a strong species, born of this planet, but not bound to it. What we once thought of as a home is merely a launching pad to an unlimited realm. Space, an infinite but reachable expanse. But before we exhaust ourselves trying to conquer this fleeing enemy, we must ask ourselves, should we conquer space? We need to conquer space no more than we need to conquer ourselves, because ultimately we are space, especially those of us who dream.